Hey, good morning guys. Hurricane Laura is here. We've been waiting for this for a few days. We weren't sure exactly how it was going to play out. Hurricane Marco kind of played itself out. It was a hurricane for a minute and then it died back down to a storm. But Hurricane Laura is going to be a full-fledged hurricane for a little while. So let's talk about Hurricane Laura. And Hurricane Laura started out in Africa. Right down here along the equator, you have a lot of direct rays from the sun. Direct rays from the sun mean the water warms up. When the water warms up to 80 degrees or more, it is evaporating and it is feeding the energy that a hurricane needs. And Hurricane Laura started out in Africa and traveled across the ocean until she got to the Gulf of Mexico. This is where she's picking up extra energy and she's turning into a full-scale hurricane. So right now, this is Hurricane Laura. Hurricane Laura is in the Gulf of Mexico. She is heading for the coast and she's gaining power. But let's figure out where Hurricane Laura started from. Hurricane Laura started from as a little bitty baby, tiny little storm off the coast of Africa. This is where hurricanes are born. Right near the equator, the water is warm. All of the direct rays of the sun are heating up that water and it's evaporating. That evaporation is turning thermal energy into kinetic energy as the air rises. Weather is an interaction between the atmosphere and the hydrosphere, the air and the water. And this interaction involves kinetic energy, which is the movement of that air and that water. That's weather. Notice how the warm air is rising, expanding, and pushing on the foil. This is demonstrating the movement of air in response to thermal energy. Thermal energy for my candles excites the air, it expands, and it rises. The same thing happens with evaporation. The water molecules are getting so excited that they are turning from a liquid water into a gas, water vapor, and as they expand they rise and then they can push up, and that's what forms the clouds and the energy for the hurricane. So what if I pour some hot water into the teacup? Will the evaporation of the teacup affect the feather? And if you look, you'll notice that the evaporating water is indeed pushing the feather around. So a hurricane needs a lot of energy, and it gets that thermal energy from the evaporation of the water of the ocean. It needs 80-degree water, and the longer it has that fuel, the larger it grows. This is a big trip, and it needs a lot to eat along the way. By the time it arrives, it could be a large tropical storm or even a hurricane. Hurricane Laura got strong across the Atlantic. It spent the last few days raining on the islands, but it didn't feed her. It was just dropping energy, releasing thermal energy as the water vapor gas turned back into liquid raindrops. They had storms, but she wasn't absorbing as much thermal energy from the warm ocean water anymore. Now she's in the middle of the Gulf of Mexico, and she's absorbing more thermal energy, and we expect that she's going to travel north, hit the coast, increase in size and strength. She's going to travel losing thermal energy because now that she's over land, she's not absorbing any thermal energy evaporation from the water. She'll drop that, she'll travel over Kentucky and Tennessee and then head back east into the Atlantic Ocean. I'm going to leave you some links to explore a little bit more about Hurricane Laura and how hurricanes form. Have a great day, guys.